Hi, my name is Abhijit and I'm an engineering manager here at Google. I've been here for slightly over 2 years and I lead a team that helps run the compute fleet to run efficiently across all of Alphabet.
Hi, I'm Divya. I'm a staff software engineer at Google. I have around 17 years of experience in designing and building distributed systems at scale. My primary area of interest is data engineering.
So in this conversation, we will walk you all through a mock system design interview with a focus on helping you understand how to approach this in a systematic manner. And at the end of this conversation, I'll also give you a summary of the things that went well and the things that could have been improved. I'm going to talk about the system requirements in a bit, and feel free to stop me at any point if you need any clarifications.
Sure.
I'm going to copy and paste the problem statement in the document itself, so that we are both on the same page. And you can start from there. The problem statement is that you are given an API that can track when a certain user listens to a certain song in a certain album, and the system that you're trying to build should be able to report on what are the top N most listened to songs, most listened to albums by user, by country, by days, months, years, etc. Does that make sense?
Yeah, it makes sense. Just give me a second, I'll go over the problem.
Sure.
Yeah, I see the question, I understand that. I have some questions before I move on to the design.
Absolutely.
I'll start with the use cases. So I assume, so it's fairly clear from the question. It's an API to get the top N songs or albums. Just want to know if there is any use case for personalization.
I think we should just focus on the API for now, and let's assume that the user experience, browser-based or mobile-based, is out of scope for now. Same for personalization as well. If we have time at the end of the interview, we can come back to it. But for now, you can assume that personalization is not in scope.
I'm just noting down the discussion that we're having. So I'm going to go into the details of the scale. I'll just assume some numbers here. Let me know if that is fine. Go ahead. So can I say there are like 400 million users to start with?
Unique users, yes, but of course you have to assume that not all of them will be on the app at all times.
So let me say then 40% of them are active.
That's a reasonable number.
And let's say on an average of 2 hours of song listening every day?
Sure, yeah, that makes sense. The amount of time might differ by region, but we'll come to it.
And also I'll assume there are around 70 million songs
in the catalog. Sounds like a reasonable number, but of course the catalog will grow every day because new songs get added to it as well.
So let's say like some 60k songs get added every day.
That's a reasonable number to assume.
What is the expected latency? This will help me to decide if it's going to be real-time processing or batch processing.
No, it's not real-time. I think it is okay if the lists are refreshed like every hour. Of course, going back to what I was saying earlier, I think there are more users in certain parts of the world, like North America and Europe has more users. They are also listening to more songs, so they would expect the lists to be updated much more frequently. But I think 1 hour is still a reasonable assumption. In certain other parts of the world, even once a day should be fine. But let's start with once an hour.
So 1 hour in certain popular regions and 1 day for less popular region. So which means that I will be keeping it configurable.
Yeah, I think that would be the right thing to do in your design.
And the query latency, can I say some 200 QPS to start with?
That's a reasonable assumption. I would like to see scalability in your design, because our hope, of course, is that the app will take off, and so you should, the traffic might grow to like 500 or 1000 QPS as well. So just make sure that you incorporate that into your design.
So should be scalable up to 1000 QPS. I'll just start with a simple design with the understanding that I have, and then we'll go into the details of the boxes.
That makes sense.
I'll start with like basic blocks.
Okay.
So before that, I just want to know like the scale of the amount of data that I'm going to process based on the numbers that we just discussed.
Yeah.
So 200 million users, let's say 3 hours a day, and which means that 36 songs by a user, if I consider like 5 minutes on an average for a song, which makes the calculation to come to like 600 million songs per day, listened songs. Okay, so our system is going to have, let's say the basic blocks are going to look like whenever user listens to a song, there is an API which the the app, whenever they're listening,
which is a tracking API that's given to you. Yes.
Yeah. So there's a tracking API. Whenever user listens to a song, the tracking API will be invoked, and the tracking API will hit a black box, let's say, which is going to process all this data.
Okay.
There are APIs which is going to give us like top N songs and top N albums, for example, and those will hit the black box, which has the process data, and it will return the top results.
In this architecture diagram, the box on the right is the black box that you will go into the details of later on. Okay,
yes.
That makes sense.
Yeah, I'll go into the details of it now. Let's say the tracking API, it gets the data, and what happens after that, I will need some sort of a queue to store the data for time being until it's processed. So it can also be the API which is doing the processing, but the bandwidth of the API will be used, and the scaling of the API, it can also always be offloaded, and we can also, when there is like a peak load, we can avoid data loss. So I would want to offload as much as possible in order to be able to scale the API and move some of the processing into the queue, and will happen after reading from the queue.
Sure.
So I'll be adding a queue right after the tracking API, which it will write to, and my choice of the queue would be Kafka. It's distributed and scalable.
Okay.
So it's industry-wide proven technology, so I'll go ahead with that.
Sure.
So yeah, and after that, so now the data is in Kafka.
Okay, so as I understand it, a new event has been captured through the API and it has landed in the Kafka queue so far.
Right, right.
Okay.
So from here, I'll have a streaming job which reads from Kafka and copies it over to a batch store. So I'm going ahead with a batch system processing here.
Okay.
Since the minimum latency is, I think the maximum latency is 1 hour, which can be processed in a batch fashion, and we can get the throughput of 1 hour from the batch systems.
Okay.
So I will have a streaming job which reads from the Kafka topic and writes it to the batch store. The store that I choose is like HDFS for now. It can be S3, it can be GCS also. Like for now, I'll choose HDFS.
Do you want to explain that choice a little bit? I think it's a fine choice. I just want to make sure that you're taking the right considerations into account.
Yeah. So it's distributed and replicated data, and it scales really well for the batch processing.
Okay, sounds good. Okay.
And so there'll be an ETL pipeline on top of this data, which would process the raw events. Let's say whatever we wrote to HDFS is song raw events, right? So it's per song listening event, and ETL will process them and it will give a schema to it. And
you want to show the schema of the song event just to be sure that we are on the same page?
Right. So the song schema is going to have, let's say, song ID, album ID. Let me just type it out here.
Okay.
User ID, location, and more information like, if it's an API, API credentials or the project, something to sort of identify the app that's invoking the API, etc. So pretty much all the IDs and minimal information that we would need to further process data. Also use like lesser bandwidth from the API.
Yeah. You've written all of this to HDFS, and so are you creating one partition per hour?
Yeah, one partition per hour would do.
Okay.
And then it can actually be like one partition per hour. Would it be creating too many small files?
Yeah, you don't want too many small files in HDFS.
Yeah, so maybe we could append it to a date directory also.
Okay.
Because these are raw events, not going to be queried often. If we store it in like a lot of data in one partition, it's going to have lesser performance on queries, which is okay. This is raw data for debugging purpose and for reference.
Okay.
So I'll go with a date partition instead of hourly to save on the namespace.
Okay.
And the schema is put on that data and then written to the song events. And song events is further processed through a same ETL or another ETL, which will sort of join it with other metadata like song metadata and album metadata, and then write it out as enriched song events.
And where is this metadata available? Is the join happening on HDFS, so that metadata is also available on HDFS?
Yeah, so the data is expected to be available in HDFS itself.
Okay.
Unless it's like a very small, like few hundreds of records which can be pulled from anywhere else as part of the batch processing.
Okay.
In this case, songs and albums, they are again millions of records. So it will be replicated over to offline data store. Okay. And then from OLTP to offline data store through couple of ways, either change log or change data capture, or through events like we do it for Kafka. Okay. And then copy it over to batch systems, in this case let's say HDFS, and then the ETL would sort of do the joins and write enriched song events. So now the schema that we initially had just the album ID and song ID. We could improve more onto it, like let's say album genre and song name, singer and so on. So whatever dimensions we would need for slicing and dicing, and location can further be derived into like city, country, and so on. So all those processing and transformation will happen, and then we'll have enriched song events. Okay. So this is again at the level of a song. It's still the same, the dimension of this table is same as what we received in the input, but it's enriched.
You want to write down the schema of that? I just want to make sure that we are on the same page on this.
Yeah, sure. Yeah, I'm just writing down the schema. So it's going to have like timestamp, date, hour, the timestamp is derived into those, and user ID, now we'll have gender, age group, which is again derived from the user data. Location will be extrapolated to city, region, song author, album genre, and then other information about API credentials.
That makes sense. Okay.
Yeah, after this the data has to be sort of aggregated. Okay. I would go with couple of options are there, which is one is BigQuery, which is pretty good in slicing and dicing, and it's good for the data analytics use cases. Or I could, since I've already chosen HDFS, I could also choose like Presto, which is very similar to BigQuery in terms of like querying the data at scale. And the APIs can directly talk to BigQuery to get the data. Okay. And but in this case, what happens is whenever there's a query, the aggregation happens on the fly, which is like a lot of compute power is being used. True. And also in the use cases when we discussed, you said that it can be refreshed at a maximum of 1 hour, which means that the data is going to be pretty much static for that 1 hour. So the queries that are happening for that 1 hour would be returning, if it's for the same set of dimensions, it would be returning the same set of data. It does make sense to compute it again. So I would choose to do the aggregations and put it in another database. Okay. From BigQuery, I'll put it in an RDBMS, for example. Okay. How
would the data be copied over from HDFS into this RDBMS?
There are two ways. One is we can write an ETL which does the aggregation and writes to the RDBMS. Okay. If we introduce BigQuery, and the queries can happen there, the ETL transformation can happen, aggregation can happen there as another query, and then you can write the results over to RDBMS. Okay. In case of BigQuery, you can use it for other analytics use cases also. Sure. If you want me to deep dive into that.
That's okay. I think we should stick to the scope that we talked about earlier. If we have time, we can come back to this.
Okay, Cool. Since we have most of the boxes defined, I want to talk about reliability.
Absolutely.
So I want to see how, when systems go down, how this design sort of copes up.
Okay.
I'll start with the tracking API. So tracking API, I would imagine I'll have load balancers and have this deployed in multiple regions, region 1 and 2, let's say, and both up and running all the time. So the load balancers can decide whichever is needed and closer or whatever, it will use that. So looking at the capacity, should I have 50-50 percentage or should I have like 100 percentage?
It's something that you have to decide on the basis of what the ROI is going to be.
Yeah, so if you're looking at like 100% no data loss and 100% data processing, then probably we'll have to go with like 200 percentage, 100 percentage in one region and other region having 100 percentage. Without which, if it's, let's say if it's down for some time, then the top songs will not be refreshed. Based on the requirement, we could either choose like 50-50 or 100-100. So
I think it's a really good approach, because sometimes the amount of effort it takes to build reliability in is not worth the goal that you're trying to aim for. So yeah, all good.
Okay, and the next component is the Kafka. So again, I would imagine having them in both the regions. So even if one region is down, the other can sort of pick it up, which means that now the data is partitioned between these two regions. So I will add an aggregated data layer, which will read from both Kafka and then keep it. Since I have two regions now, the data will be replicated over in both the regions, the aggregated data, and then rest of the processing is batch processing. It doesn't have to happen in both the regions. I'll keep it on in region 1, let's say, and region 2 will have the data. Any moment you can start the pipelines and it will start running. So I'll keep it as a backup. And region 1 will process all this data and then dump it into RDBMS, which is the last output database. That I would again have it in both the regions. If that is down, then I would still need a backup. The serving has to happen.
Part of it,
So I would have it in both the regions. The region 1 will process and write it to both region 1 RDBMS and region 2 RDBMS. That is about the reliability. Do you want me to cover?
I think this is good. Are there other aspects of the design? If you had more time, are there other aspects of the design that you would have liked to focus on?
Yeah, definitely. So I want to focus on like monitoring alerts. We have to have health checks in all of these components. Also the data health check, which is system health check for monitoring, and then having the right set of alerts to address and sort of notify. The data health check, which is basically the data quality, making sure that whatever data that's coming in, that's processed right in the right way, and then it's in the right expected format, and there's no data loss in the processing of the data. Adding the right checks and balances between each of the pipelines, or right after the processing of the data. I would want to talk about that. And also like when the systems are down, let's say we are restarting it, how do we backfill? How do we recover and get it back to normal state? So those kind of topics I would want to go into the details if time permits.
No, this is good. I think we've made a really good progress in terms of the design that we wanted to have, and I think we can end this conversation here. As would be evident from how the conversation went, the candidate proceeded with the system design in a very methodical manner. They started by capturing the high-level requirements, called out assumptions, and then moved on to the high-level design. They spent only the right amount of time in the low-level design of components without getting mired in the minutiae that would have been otherwise overwhelming to them and to the interviewer. They were clearly comfortable doing back-of-the-envelope calculations, which is always a good sign. Another important thing that they did right was that they were talking through their thought process at all times. That helped me understand how they were thinking and how they were approaching the problem, as well as to be able to nudge them in the direction that I wanted the conversation to go. They were also very receptive to feedback. So anytime there was a nudge to take the conversation in a particular direction, they understood what the expectation was and they changed course accordingly. There were a couple of places where they tried to increase the scope of the problem to be more than what was really expected. This is one thing that I would say folks need to guard against. You do not have to solve a problem that the interviewer is not asking you to. So stick to the script, stick to what the interviewer is asking. But in this case, the candidate, like I said, was very receptive to feedback. So we were able to get all the salient points of the design in the time that we had. If you have multiple options for a design decision, do a trade-off analysis proactively and show your interviewer how you arrived at the optimal one. Try and cover as many non-functional aspects as possible in your design to ensure the system is scalable, highly available, secure, conservative yet realistic in its resource expectations, and easy to operate and maintain.